Dr. Babasaheb Ambedkar Open University.
Welcome my dear students. You are watching Software Engineering lecture series. Here we are going to conduct a lecture on the unit 2, which is software process model. The agenda of the topic is learning objective. Actually, the main objective of the chapter is to introduce concept of software process, right? So, software process is set of activities carried out throughout software development. So, when you will learn this chapter, then you will be able to understand concept of software process, then you will also learn about various linear process models, and at last you will gain knowledge about advantages and disadvantages of various process models. So, then we will see phases of waterfall model, then we will see classical waterfall model, advantages and disadvantages of classical waterfall model, then you will see some of the uses of classical waterfall model, and at last we will see some of the examples of waterfall model. So, on your screen you can see introduction of the waterfall model. So, actually every software engineering organization has a described set of framework activities as part of their software development strategy. So, this set of prescribed framework activities are known as process models. So, every software project has different framework activity. Thus, for different software project, different process model is applied based on nature of project. Then methods, or we can say available tools, controls and deliverables required. So, these process models are known as SDLC. Actually, SDLC stands for Software Development Lifecycle. All process models are categorized into two categories. First one is linear and second one is evolutionary. In this unit, we will discuss about linear software process models. So, the classical waterfall model is the basic software development lifecycle model. It is very simple but idealistic. Earlier, this model was very popular, but nowadays it is not used. But it is very important because all the other software development lifecycle models are based on the classical waterfall model. So, waterfall model is a classical software development methodology that was first introduced by Winston W. Royce. Actually, in the year 1970, it was invented. It is a linear and sequential approach to software development that consists of several phases that must be completed in a specific order. Now, let's understand the various phases of waterfall model. So, phases of waterfall models are on your screen, which includes requirements gathering and analysis, design, implementation, testing, deployment and maintenance. So, if we talk about requirements gathering and analysis, then its first phase involves gathering requirements for stakeholders and analyzing them to understand the scope and objectives of the project. Then design means once the requirements are understood, the design phase begins. Actually, this involves creating a detailed design document that outlines the software architecture, user interface and system components. Then third one is implementation. So, the implementation phase involves coding the software based on the design specifications. This phase also includes unit testing to ensure that each component of the software is working as expected. Then fourth phase is testing. So, in the testing phase, the software is tested as a whole to ensure that it meets the requirements and is free from defects. Then the fifth one is deployment. Once the software has been tested and approved, it is deployed to the production environment. Then the last one is maintenance. So the final phase of the waterfall model is maintenance, which involves fixing any issues that arise after the software has been deployed and ensuring that it continues to meet the requirements over time. Now the classical waterfall model divides the life cycle into set of phases. So this model considers that one phase can be started after the completion of the previous phase. That is, the output of one phase will be the input to the next phase. Thus, the development process can be considered as a sequential flow in the waterfall model. Here, the phases do not overlap with each other. So, in the next slide, the different sequential phases of the classical waterfall model available on your screen. So, let's now learn about each of these phases in detail. So, first one is feasibility study. Now, the main goal of this phase is to determine whether it would be financially and technically feasible to develop the software or not. Then the feasibility study involves understanding the problem and then determining the various possible strategies to solve the problem. Now, these different identified solutions are analyzed based on their benefits and drawbacks. So, the best solution is chosen and all the other phases are carried out as per this solution strategy. Then the second one is requirements analysis and specification. So, the aim of the requirement analysis and specification phase is to understand the exact requirements of the customer and document them properly. So, here this phase consists of two different activities, which is requirement gathering analysis and requirement specification. Now, let us understand requirement gathering and analysis. So, firstly, all the requirements regarding the software gathered from the customer and then the gathered requirements are analyzed. Now, the goal of the analysis part is to remove incompleteness and inconsistencies. So, an incomplete requirement is one in which some parts of the actual requirements have been omitted, and an inconsistent requirement is one in which some part of the requirement contradicts some with other parts. Then the next one is requirement specification. So, these analyzed requirements are documented in a software requirement specification, which is SRS. So, SRS document serves as a contract between the development team and the customer. Any future dispute between the customers and the developers can be settled by examining the SRS document. Then the third one is design. So, the goal of this phase is to convert the requirements acquired in the SRS into a format that can be coded in a programming language. It includes high level and detailed design as well as the overall software architecture. A software design document is used to document all this effort actually. Now, the next one is coding and unit testing. In the coding phase, software design is translated into source code using any suitable programming language. Thus, each designed module is coded. Now, the aim of the unit testing phase is to check whether each module is working properly or not. Then the next one is integration and system testing, which is fifth phase. So, here integration of different modules is undertaken soon after they have been coded and unit tested. Now, integration of various modules is carried out incrementally over a number of steps. So, during each integration step, previously planned modules are added to the partially integrated system and the resultant system is tested. Finally, after all the modules have been successfully integrated and tested, the full working system is obtained and system testing is carried out on this particular situation. Now, system testing consists of three different kinds of testing activities as described on your screen. The first one is alpha testing. So, alpha testing is the system testing performed by the development team. Then we have beta testing. So, beta testing is the system testing performed by a friendly set of customers. Then next one is acceptance testing. So, after the software has been delivered, the customer performed acceptance testing to determine whether to accept the delivered software or reject it based on the satisfaction of particular product. Then we have maintenance. So, maintenance is the most important phase of the software life cycle. The effort spent on maintenance is 60% of the total effort spent to develop full software. So, there are basically three types of maintenance. First one is corrective maintenance. So, this type of maintenance is carried out to correct errors that were not discovered during the product development phase. Then we have perfective maintenance. This type of maintenance is carried out to enhance the functionalities of the system based on the customer's request. And then we have adaptive maintenance. So, adaptive maintenance is usually required for porting the software to work in a new environment, such as working on a new computer platform or with a new operating system. Now, in the next slide, we have advantages of classical waterfall model. So, the classical waterfall model is an idealistic model for software development. It is very simple, so it can be considered the basis for other software development lifecycle models. There are some of the major advantages of this SDLC model you can see on your screen, which are like this. This model is very simple and easy to understand. Then the second one is phases in this model are processed one at a time. Then each stage in the model is clearly defined. Then this model has very clear and well understood milestones. Then we have process. Then we have process, actions and results are very well documented. Then reinforces good habits, actually define before design and design before code. We can describe this point like this. Then this model works well for smaller projects and projects where requirements are very well understood. Then in the next slides we have some of the drawbacks of the classical waterfall model. So, the classical waterfall model suffers from various shortcomings. Basically, we can't use it in real projects, but we use other software development lifecycle models which are based on the classical waterfall model. So, there are some major drawbacks of this model, like no feedback path, then difficulty to accommodate change requests, then we have no overlapping of phases, then limited flexibility, then limited stakeholder involvement, then late defect detection, then we have lengthy development cycle, not suitable for complex projects. So, no feedback path here. In the classical waterfall model, evaluation software from one phase to another phase is like a waterfall. So, it assumes that no error is ever committed by developers during any phase. Therefore, it does not incorporate any mechanism for error correction. Then we have next one is difficult to accommodate change request. So here we can say this model assumes that all the customer requirements can be completed and correctly defined at the beginning of the project, but actually customers requirements keep on changing with time, right? So it is difficult to accommodate any change request after the requirement specification phase is completed. Then we have next one, which is no overlapping of phases. So this model recommends that a new phase can start only after the completion of the previous phase, right? But in real projects, this can't be maintained. To increase efficiency and reduce cost, phases may overlap. Then we have limited flexibility. Here the waterfall model is a rigid and linear approach to software development, which means that it is not well suited for projects with changing or uncertain requirements. So once a phase has been completed, it is difficult to make changes or go back to a previous phase. Then we have limited stakeholders involvement. Now the waterfall model is a structured and sequential approach, which means that stakeholders are typically involved in the early phases of project, where requirement gathering and analysis, but may not be involved in the later phases like implementation, testing and deployment. Then we have next point, late defect detection, right? So in the waterfall model, testing is typically done towards the end of the development process. So this means that defects may not be discovered until late in the development process, which can be expensive and time consuming to fix actually. Then we have lengthy development cycle. Now the waterfall model can result in a lengthy development cycle, as each phase must be completed before moving on to the next phase. So this can result in delays and increase the costs if requirements change or new issues arise. Then next one is not suitable for complex projects. Here the waterfall model is not well suited for complex projects, as the linear and sequential nature of the model can make it difficult to manage multiple dependencies and interrelated components actually. Now in the next slide, we have some of the uses of classical waterfall model. So some common uses of the waterfall model include like large scale software development projects, then safety critical systems, government and defense projects, then projects with well defined requirements, projects with stable requirements. So we have first point, that is large scale software development projects. So let's define it. Actually the waterfall model is often used for large scale software development projects, where a structured and sequential approach is necessary to ensure that the project is completed on time and within budget. Then second one is safety critical systems, right? So here the waterfall model is often used in the development of safety critical systems such as aerospace, medical systems, where the consequences of error or defects can be severe. Then we have government and defense projects. Here the waterfall model is also commonly used in government and defense projects, where a rigorous and structured approach is necessary to ensure that the project meets all requirements and is delivered on time. Then fourth one is projects with well defined requirements. Now the waterfall model is best suited for projects with well defined requirements, as the sequential nature of the model requires a clear understanding of the project objectives and scope. Then fifth one is projects with stable requirements. Now the waterfall model is also well suited for projects with stable requirements, as the linear nature of the model does not allow for changes to be made once a phase has been completed, right? Then in the next slide, now let's see some of the examples of waterfall model. So it is the last slide of this unit. So in the olden days, waterfall model was used to develop enterprise applications like customer relationship management (CRM), then human resource management systems like HRMS, then supply chain management systems, inventory management systems, then point of sales means POS systems for retail chains, etc. Now, waterfall model was used significantly in the development of software till the year 2000. Now, even after the Agile Manifesto was published in 2001, waterfall model continued to be used by many organizations till the last decade. So these days, most projects follow Agile methodology. So some form of iterative model or one of the other model depending on their project specific requirements. So in the olden days, applications developed in waterfall model like CRM system, supply chain management system, etc. would usually take a year or longer to develop. However, there are some areas where waterfall model was continued to be preferred. So let's discuss those areas. So consider a system where human life is on the line, where a system failure could result in one or more deaths. Then we can say in some countries such mistakes could lead to imprisonment for those who are accountable. Then consider a system where time and money were secondary considerations and human safety was first. So let's discuss some more such situations where waterfall model was the preferred approach actually. So development of Department of Defense means DoD, military and aircraft programs followed waterfall model in many organizations. So this is because of the strict standards actually and requirements that have to be followed. So in such industries, the requirements are known well in advance and contracts are very specific about the deliverable of the project, right? Then DoD. DoD agencies typically considered waterfall model to be compatible with their acquisition process and rigorous oversight process required by the government. So having said that, even these industries are being disrupted by the use of iterative model and agile methodology by organizations like SpaceX and others. Waterfall model was also used in banking, healthcare, control system for nuclear facilities, then space shuttles, etc. So in this unit, we have seen in detail waterfall model. Happy learning.